Something has happened to 3I ATLS. And whatever it is, it doesn't belong in any physics textbook we've ever written. On the latest telemetry, the object begins accelerating as if someone, somewhere, pressed an invisible throttle. No noise in the data, no uneven outgassing, no natural explanation. Just a clean, deliberate rise in speed. And the worst part, its new trajectory isn't drifting past Mars, it's sliding toward a zone where even a fractional change in vector could end an impact. NASA's simulations spit out the odds of this happening by chance, lower than winning the lottery twice in one day. If it looks like a controlled maneuver to you, you're not alone. Stay with me. We're going to uncover why Atlas made scientists go silent the moment it shifted its course. And if this grabbed you even a little, subscribe. You're going to want to hear what comes next. At 2:13 a.m., deep inside the dimly lit operations room of the Jet Propulsion Laboratory in Pasadena, Dr. Ethan Rains leaned closer to the monitor, squinting as a fresh stream of telemetry scrolled across the screen. Fluorescent lights hummed overhead, the kind of sterile buzz that always felt too loud this time of night. Half the building was asleep, the other half pretended to be. But Rains wasn't tired tonight. He was unsettled, and he didn't yet know why. A tiny blue dot labeled 3I ATLS crept along a plotted trajectory. To a casual observer, it was nothing special. Just another interstellar wanderer, the third ever detected, heading on its hyperbolic exit path. A visitor passing through, never to return. Except, something was wrong with its speed. Not catastrophically wrong, not Hollywood disaster movie wrong, but wrong in the exact, quiet, insidious way that made seasoned scientists straighten their backs for a moment and stop breathing. The data stream updated again. Rains froze. There it was, the same anomaly he'd seen earlier, faint, but undeniably persistent. The object's velocity vector had shifted again, a tiny deviation measurable only in tenths of a meter per second. Insignificant to anyone else, impossible to him. He whispered it under his breath, barely audible. No. Now that can't be real. 3IATLS was supposed to move ballistically, following gravity and nothing else. No engines, no internal structure capable of producing thrust, no mechanism to push itself through space. Comets don't improvise trajectories. Rocks don't change their mind mid-flight. He ran the datastet again, checking timestamps, calibration references, instrumental corrections. His hand trembled slightly as he verified each number. He repeated the process, then repeated it again. Every time, the result aligned perfectly. Velocity increased by 0.14 meters per second, direction shifted by 0.02 degrees. He sat back, pulse picking up. "Wake up," he murmured toward his empty office chair. Not that anyone was sitting there to hear him. But someone had to. Someone needed to witness the moment when the laws of orbital mechanics politely raised a middle finger. Rains rose from his seat and hurried down the hallway, past silent cubes and automated status displays. He pushed into the adjacent lab, where Dr. Lena Moretti, night operations coordinator, sat reviewing spectroscopic data with headphones on. He tapped her shoulder. She pulled off one ear cup. "What, Ethan?" "I need you to look at something." Her eyebrows lifted at the tone. He wasn't prone to drama. If anything, Ethan Rains was known for being aggressively calm. Metronome heartbeat. Glacial patience. So when he sounded rattled, people listened. He led her to his terminal. The data flickered in soft blue. She studied it, jaw tightening by the second. "Run it again." He did. She leaned in, hands braced on the desk. "That looks like a controlled correction." "I know." "Did you check the raw frames?" 3 times. "And the astrometric fits?" "Twice." A beat of silence stretched between them. "Ethan," she said carefully, "nothing natural produces thrust like that without visible outgassing." "I know." And comets don't... I know. She exhaled, long and low. We need the team. They spent the next 20 minutes pulling in the night shift analysts, orbital dynamicists, image processors, and anomaly verification specialists. People arrived in hoodies and wrinkled jeans, holding coffee cups and wearing expressions of reluctant curiosity. "Why are we all here?" someone asked. Ethan didn't answer. He just threw the data on the main projection wall. The room fell silent. 15 scientists stared at the abnormal trajectory shift of an object that should have been utterly predictable. At 3:01 a.m., Dr. Marcus Yu, the youngest dynamicist on the shift, broke the silence. "That looks like intentional." A few people chuckled reflexively, the kind of laughter that comes not from amusement, but from fear wearing a silly hat. Lena shot him a look that said not now. "We should consider natural explanations first," she said. Ethan nodded. Agreed. But the elephant was already in the room. Huge, quiet, unmistakable. 3I-ATLS was moving as if it had a say in its own trajectory. By sunrise, the anomaly was confirmed by 2 independent ground-based observatories and a deep sky satellite survey. Ethan hadn't slept. No one had. The official morning meeting was scheduled for 9 a.m., but by 8:10 the operations room was already packed. People stood along the walls, crowding every terminal, whispering theories under their breath. On the main display, the projected path of 3I-AT Atlas was highlighted in yellow, overlaid against its expected gravitational trajectory in gray. The divergence was subtle but ominous, like a crack forming in a dam. Dr. Sarah Caldwell, head of Unusual Dynamics, stepped to the front. "Let's begin," she said, pressing a button to bring up the first slide. "We have a velocity deviation of 1 to 2 orders above expected non-gravitational perturbations. Preliminary models indicate a change inconsistent with standard comet behavior." She turned to the room. "In plain English, comets don't do this." There was no dramatic music, no thunderclap, just the low collective inhale of 20 scientists slowly realizing they had a problem with no category. "We'll approach this systematically," Caldwell continued. "First, natural causes. Let's talk about outgassing." Marcus pulled up simulated outgassing vectors, showing jets of sublimating ice pushing the nucleus. It was pretty. Colorful arrows splayed like the legs of a neon spider. But the model was insufficient. The force required didn't match the energy available. "Unless Atlas contains a reservoir of supervolatiles we've never observed before," Marcus said, "outgassing can't explain the shift." "Next," Caldwell said, "fragmentation." Lena stepped forward, bringing up high-resolution composite images. 3I-AT Atlas appeared intact, aside from a faint dust halo. "If it fragmented," she said, "we'd see changes in brightness patterns. The debris would produce measurable photometric flicker. We don't see that." "Solar radiation pressure?" someone else offered. "Too weak." Ethan responded immediately. "Orders of magnitude too weak." "What about instrumental error?" "The anomaly appears across 4 independent data streams. It's real." A ripple of unease spread through the room. Someone murmured, "Then what's left?" No one wanted to answer. Finally, Caldwell clicked to the next slide. A single sentence. "Course correction?" The room exhaled all at once, a mixture of disbelief and grim fascination. A few people chuckled nervously. "Oh, come on," said a senior spectroscopist in the corner. "We're not seriously considering—" "We're not ruling anything out," Caldwell said sharply. Then more quietly, "Not yet." Ethan felt his heart thudding. He'd never believed in extraterrestrial technology. He didn't believe in miracles, conspiracies, or convenient anomalies. He believed in equations, instrumentation, and error margins. But 3I-AT Atlas was ignoring all 3. That evening, as sunlight drained from the sky and the JPL campus settled into a dusky hush,
Ethan returned to the operations room. He wasn't on shift anymore. He was supposed to go home, sleep, drink water, be a person again. Instead, he replayed the data, frame by frame, pixel by pixel. At 11:52 p.m., his hand froze over the trackpad. The object's course was no longer merely deviating, it was testing a new vector. A slow, gradual arc, too gentle to be mistaken for simple drift, too coherent to be noise. Like something stretching its limbs after a long, dormant journey, or like a driver nudging the steering wheel. He replayed it 5 times until the hair on his arms stood up. He sent the clip to Lena with one sentence: "You need to see this." Within minutes, she appeared at the doorway, breath slightly unsteady from hurrying. "Show me." He zoomed in on the trajectory shift. She leaned closer, closer still. Her voice was low, almost a whisper. "That's not random." "No, it isn't." He highlighted the deflection angle, 0.12 degrees, then the acceleration spike, 0.23 meters per second squared. She stepped back, visibly unsettled. "We have to alert Caldwell." "I know." "And the NASA Planetary Defense Coordination Office." "I know." Her voice tightened. "Ethan, do you understand what this means?" He nodded, but she said it anyway. "It's changing course again." The next 48 hours blurred into a haze of numbers, simulations, emergency Zoom calls with the University of Colorado, MIT, and Caltech teams. Every hour brought new telemetry, and every update made the situation worse.
The deviation grew. The trajectory shifted further from the expected hyperbolic exit path. 3I Atlas wasn't just wandering, it was turning. The phrase active guidance appeared in 3 separate internal emails. No one wanted to use it publicly, even within NASA channels, but it hung in the air like smoke. By the 3rd night, Ethan stared at the new simulation results with a knot in his stomach. The yellow projected path, the actual path, drifted closer to the orbital track of Mars. Anxiety rippled through the team. "This is insane," someone whispered. "Why would an object from interstellar space approach Mars? What are the odds?" Lena cut him off. "Don't anthropomorphize it. We don't know that it's choosing anything." But Ethan heard the tremor in her voice. Martian intercept windows were narrow and precise. Accidental alignments happened, sure, but they weren't accompanied by deliberate-looking acceleration vectors. He checked the ephemeris again. Projected distance to Mars, shrinking. Estimated relative approach speed, increasing. Time until closest approach, 214 days. He felt sweat bead along his spine. It didn't feel like a coincidence. At 3:12 a.m., because nothing important ever happened at sane hours, an alarm tone chimed from the main console. A yellow banner flashed across the screen. Deviation exceeds 12 sigma. 12 sigma. Statistically impossible. Rains felt his mouth go dry. He pulled up the raw data. The object's vector wasn't bending, it was pivoting, as smooth as a fingertip tracing a curve. He whispered it aloud. "He's changing course." He didn't know why he chose the word he. No one corrected him. The room filled again as the team assembled, some half-dressed, others clutching coffee cups like lifelines. They ran the simulation using every plausible natural input. Outgassing? Insufficient by a factor of 20. Fragmentation? Would produce irregular acceleration, not a controlled arc. Solar tides? Too weak. Magnetic interaction? Irrelevant at this distance. Nothing, absolutely nothing, behaved like the data on their screens. One of the senior analysts, Dr. Harmon, scrubbed a hand down his face. "This can't be happening. Objects don't reorient themselves mid-flight." "Tell that to Atlas," Lena snapped. Caldwell stepped forward. Her voice was low and steady, but her eyes betrayed the fear she fought to suppress. "Ladies and gentlemen,
We are witnessing behavior without a natural precedent. Until further notice, all analyses must remain strictly internal. No leaks, no unscheduled communications. We will understand this, but not until we rule out every alternative. She paused, looking around the room. And we are running out of alternatives. The lights hummed, the monitors glowed, and something in the trajectory of 3I Atlas continued to shift with unearning grace. By dawn, the scientists were exhausted, hollow-eyed, and terrified of closing their laptops, but fear kept them awake. Ethan reviewed the telemetry again, placing overlays from the past week on top of the predicted arc. The deviation wasn't just growing, it was accelerating. The differences formed a pattern, an elegant curve with clear mathematical intention. He felt sick. Patterns meant purpose. Purpose meant agency. He replayed the earliest frames from the night he had first noticed the anomaly. The motion had been minuscule, almost dismissible. But now seeing it with new understanding, it was obvious. The first deviation had been a test, a nudge, a probe, a prelude. 3I Atlas had been adjusting long before they realized it. A chill ran through him, the cold, clean clarity of dread. He whispered into the empty room. "What are you trying to do?" The object on the screen offered no answer. It only drifted further along the impossible line it had chosen. By the end of the week, the NASA task group delivered its preliminary statement to internal leadership. At the bottom of the report, a single sentence stood out. Observed acceleration patterns are inconsistent with cometary physics and remain unexplained.
A diplomatic way of saying, this should not exist. The room fell quiet again as the implications sank in. Marcus finally broke the silence. What if... Don't say it, Lena muttered. He said it anyway. What if it's not a comet? No one laughed this time. The data marched on, cold and indifferent, a silent rebellion against the universe they thought they understood. And 3I Atlas kept moving, faster, straighter, sharper, as if something deep within it had awakened, as if it knew exactly where it was going and why. Dr. Lena Moretti had been awake for 34 hours when the anomaly review session finally began. The JPL conference room looked like a war room. Dim lights, glowing screens, half-drained coffee cups, small clusters of scientists speaking in low, tense voices. No one dared to speak too loudly. The air itself felt brittle, like a glass sheet stretched too thin. On the main screen stood a still frame, 3I Atlas, velocity profile last 96 hours. Nothing about it looked normal. "Let's begin," Caldwell said, her voice calm but stripped of warmth. "We're moving to Phase 2, full-spectrum natural cause elimination." Phase 2 was always where the optimism died. Ethan sat near the front, twitchy, tapping one knee rapidly under the table. He wasn't trying to be dramatic, he simply couldn't stop. His body seemed to understand something his mind refused to acknowledge. Caldwell gestured to Lena. "Start without gassing." Lena stepped forward, fingers trembling slightly as she loaded the model. On screen, a 3D rendered comet nucleus rotated, its surface dotted with theoretical volatile jets. Blue arrows depicted sublimation thrust. This is the baseline outgassing model, assuming typical CO2 and CO ratios. If Atlas behaved like an ordinary long-period comet, its acceleration would fall somewhere along this curve. The blue curve pulsed gently. But Atlas doesn't follow this curve. Its acceleration falls here. A red dot appeared far above the curve. The room stiffened. That's an order of magnitude discrepancy. "More than that," Lena said. "This is the strongest natural jet we can reasonably propose." She pressed another button. The screen updated. "This is what would be required to match the observed acceleration.
A massive yellow vector appeared, pointing from the comet's terminator region, bigger than any jet ever detected. Ethan winced. It was obscene, like drawing a fire hose on a snowflake. Impossible, said Dr. Harmon flatly. There isn't enough thermal load to produce that thrust. It violates conservation profiles, added Marcus. Caldwell nodded. So we rule out outgassing as the primary cause. Lena stepped aside. The exhaustion in her expression was visible, almost painful. Fragmentation, Caldwell said. Ethan stood. His turn. He loaded a time series of brightness data. A faint halo shimmered around Atlas, the usual dust coma. He tested for microfragmentation. If small pieces were shedding off in bursts, they could theoretically alter the momentum of the nucleus. And, Caldwell asked, he highlighted a section of the brightness data. Stable, smooth. No flicker, no spikes, no debris shards with differential acceleration. The nucleus is intact. He flipped to a structural model, and, even if fragmentation were occurring, the acceleration profile would be chaotic, not coherent. Atlas is accelerating in a straight, predictable arc. Predictable, Marcus repeated under his breath, as if the word tasted wrong. Caldwell nodded again. Rule out fragmentation. Next, solar pressure. Marcus took this one, dragging the solar pressure model onto the display. He didn't bother giving a speech. This force is 17 times too weak, he said bluntly. Atlas weighs too much to be pushed like that. He slid the model off the screen. Next, the team rotated through every known explanation. Electrostatic effects, too small. Solar wind charge coupling, non-existent at this range. Gas pocket explosion, would have produced a sharp spike, not a smooth curve. Yorp torque, irrelevant. Instrumental calibration, confirmed clean. Relativistic aberration, fantasy. Caldwell watched silently as each idea was proposed and then cut down. The process took 2 hours, but it felt like 10. At last, she spoke. Everything natural has failed to explain the deviation. The sentence hung in the air like smoke. Someone coughed. Someone else whispered, "So what are we saying?" No one answered. Instead, Caldwell clicked to the final slide. Unexplained acceleration, 3IATLS. We move to phase 3, she said quietly. Behavioral analysis. The room went utterly still.
Behavioral. As in something behaving, as in active. Ethan felt the floor tilt beneath him. His heartbeat throbbed in his throat. He had spent his entire life believing the universe was a place of elegant physics, not intention. But here they were. Caldwell dimmed the lights and pulled up the trajectory overlay. The expected path, a simple hyperbolic escape curve, shone in faint gray. The true path, the one Atlas was choosing, glowed in neon yellow. It curved, barely, subtly, but undeniably. "Watch carefully," she said. She pressed play. The yellow line shifted, subtle, graceful, intentional. A hush fell over the room, not fear yet, but awe. The kind of quiet that falls over people witnessing something ancient and impossible. "It's adjusting," Ethan whispered. Lena looked sharply at him. "Say that again?" "It's adjusting. Not drifting, not being forced. It's performing a correction." Caldwell exhaled slowly. If this is a correction, then the motion has to follow a predictive pattern. She turned to Marcus. "Test it." He typed rapidly, pulling up a curve-fitting algorithm. The room watched the data points cluster into a line. The line snapped into place, a perfect arc. The scientist froze. "That's intentional," Marcus said, voice cracking. "It's an intentional curve." The word intentional carried a weight the room could not hold. Someone whispered, Jesus Christ. Caldwell steadied herself. Before anyone jumps to conclusions, agency is a last resort hypothesis. But the math is concerning. Ethan stared at the arc. It wasn't just mathematical, it was elegant, calculated. Let's run light curve analysis, Lena said quickly, desperate to break the spell. There has to be outgassing we're not seeing. She loaded the spectrographic data, zooming into the coma. Chemical signatures scrolled across the display. H2O, CO2, CO. Trace organics. Normal. 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 Nothing powerful enough to explain the thrust. Nothing unusual at all. Marcus swallowed. So, how do we explain a maneuver with no fuel? Caldwell didn't answer because she didn't know. The following day, the JPL team held an emergency briefing with NASA headquarters, the Goddard Space Flight Center, and the Planetary Defense Coordination Office. It was the kind of meeting that took weeks to schedule under normal circumstances. Today, it happened in under 4 hours. The call connected. The screen filled with faces, some tired, some irritated, some alarmed. No one was smiling. Caldwell summarized the findings. She was concise, factual, clinical. She didn't dramatize, she didn't speculate, but the data did all the dramatizing for her. When the acceleration curve appeared, a director from Goddard leaned forward, squinting. You're telling us this is verified? 4 independent observatories. And you're ruling out outgassing? We're ruling out all natural causes. The director exhaled, long and slow. Good God! A silence followed, heavy, oppressive, full of unspoken fears. Finally, someone from PDCO said what everyone was thinking. Could this be a non-natural object? Caldwell didn't answer. Lena's hand tightened around her pen until it cracked. Ethan stared down at his notebook, unable to speak. The officials quickly shifted topics, as if afraid of their own question. They discussed observational strategy, data confidentiality, the necessity of limiting public release until explanations were verified. But the question lingered. What if 3I Atlas wasn't a comet? What if something else had entered the solar system? By the end of the week, the phrase course correction had quietly become taboo. Too loaded, too speculative, too dangerous. Scientists started using softer terms: non-gravitational influence, excess acceleration, trajectory adaptation. But in late-night meetings, behind closed doors, they used the real term: maneuvering. Ethan hated the word. It implied intention, and intention implied a mind or a mechanism following instruction. But that's what the math said. The divergence wasn't random, it wasn't chaotic, it wasn't accidental. It was deliberate. He sat alone at his terminal one late night, replaying the motion, not the numbers, the motion itself. Frame by frame, a smooth bend, almost delicate. He felt something strange then. Not fear, not fascination, recognition. He'd seen similar curves before, not in comets, not in rocks, but in spacecraft. When a probe adjusted trajectory to reach a flyby point, when a rover corrected its descent interface, when a satellite curved toward an intended orbit. Controlled arcs. Ethan. He startled. Lena stood in the doorway. You need to see this. His stomach tightened. What now? She flicked on the main monitor. A new plot appeared, one he'd never seen. A combined data set showing the deviation angle over time. It wasn't chaotic. It wasn't random. It was accelerating in a perfect exponential pattern. Ethan swallowed hard. That's impossible.
I ran it 3 times. Jesus. Lena stared at the curve. It's like it's learning, finding a trajectory. Ethan stood slowly. The hair on his arm stood up. It's steering. That's what it looks like. He stepped closer, voice barely audible. But steering toward what? Lena didn't answer. She didn't have to. On the right side of the screen, highlighted faintly in orange, floated a thin circular orbit. Mars. The team met again at dawn, pale and exhausted, nerves shredded. This doesn't prove intent, Caldwell insisted, even as her voice wavered. It only proves correlation. Correlation with what? Marcus shot back. A natural object doesn't perform a 0.12-degree turn toward a planetary orbit. It could be a coincidence. Coincidence doesn't generate an exponential steering curve. Caldwell tensed, but didn't argue. Because deep down, she knew. The first breadcrumb was the tiny acceleration anomaly. The second, the deviation arc. The third, the predictive exponential curve. And now, the alignment with Mars's orbit. Breadcrumbs weren't supposed to lead to answers like this. Marcus leaned forward, palms flat on the table. I think we need to say the word. No, Caldwell said. We have to. No. It's behaving intentionally. Ethan felt the words like ice water in his veins. But Marcus wasn't done. And if it's intentional, then something is controlling it.
The room fell dead silent. Outside, dawn spread across the sky, warm and gentle, completely unaware that humanity had just crossed an invisible threshold. Ethan stared at the trajectory again, pulse skittering. Three-Eye Atlas was bending its path toward Mars. A comet shouldn't do that. A rock couldn't. Nature wouldn't. Something was wrong. Something was coming. And for the first time, Ethan Raines wondered if the universe didn't just contain mysteries. He wondered if one was looking back. At first, no one reacted. The shift in Atlas's trajectory looked like noise, another late-night statistical hiccup that would evaporate by morning. That's what Dr. Marissa Hale told herself as she pinched the bridge of her nose, staring at the 3 plots glowing across her screens inside NASA's Jet Propulsion Laboratory in Pasadena. It was 2:13 a.m. The building was nearly empty, a hollow steel cathedral filled with the soft hum of servers and the low static whisper of the air system. But then the numbers moved again. A shift, subtle, almost polite, just a few thousandths of a degree in its vector. Nothing dramatic, nothing cinematic, nothing that should have made her stomach clench the way it did. Yet there it was, a smooth, steady deviation. A deviation that held. "Don't do this to me," she whispered, leaning closer, dragging a new window across the screen to overlay the predicted path with the observed one. The predicted arc sat crisp and certain, a perfect white curve based on gravity alone. The observed path, the one she refused to believe, was beginning to peel away from it like a thin hair curling in slow motion. That curl shouldn't exist. Gravity didn't do that. Outgassing didn't do that. Not like this. Not with this directionality. Not with this smoothness. She ran the data again, forcing herself to count her breaths slowly, the way she'd learned back when she interned at the Keck Observatory and panic attacks were still new to her. She reran the pipeline. She recalibrated the raw frames. She checked timestamps, camera noise, reference stars. Again, the same. The curl remained. Her pulse hammered. At 2:29 a.m., she sent a message to the internal Slack channel for the Atlas Working Group. Hale, needs second eyes on 3-eye Atlas telemetry now. Possible deviation from grav-only trajectory. Running triple confirmation, but want independent look. She expected silence. Everyone normal was asleep. Instead, Dr. Stephen Rourke, MIT. Looking now. Are you sure this isn't instrument drift? Hale. If it is, it's synchronized across 3 systems. A pause. And then, Rourke. Checking. A longer pause. Long enough that Marissa's hands started to shake. Finally, Marissa, what are we looking at? Her throat tightened. Because that was the question, wasn't it? What were they looking at? By 3:10 a.m., 6 researchers were online. At 3:25, the East Coast group joined in. At 3:40, someone from ESA chimed in with, "We see it too." At 4:12, a private Zoom call opened, cameras flickering to life across time zones. Pale faces, tired eyes, the low-lit backgrounds of bedrooms and offices lit only by screens.
No one bothered with pleasantries. Dr. Leon Ramirez from Johns Hopkins spoke first. "All right," he said, rubbing his jaw. "Let's not jump to conclusions. What's the simplest explanation?" Marissa exhaled. Right. They were scientists. Order, not panic. "The leading candidate is uneven outgassing," she said, clicking to the next slide she'd thrown together in 20 frantic minutes. "If Atlas is venting asymmetrically, it could generate thrust." "No," Rourke interrupted gently. "Not in that direction." He shared his own model, a series of simulated plume jets representing possible gas ejections from different regions of the nucleus. Blue lines showed expected perturbations. None matched what they were seeing. "CO outgassing would push in the opposite direction," Ramirez muttered. "Water vapor is too weak at this solar distance. Dust jets? Maybe. But—" He trailed off. Marissa finished it for him. "But jets aren't that consistent." This deviation was consistent, smooth, deliberate. A voice crackled in unexpectedly. Dr. Naomi Choi from Caltech, joining late. "What about microfragmentation? Tiny pieces breaking off could redistribute mass, and—" "Nope," said a low voice. Dr. Alan Kessler from ESA. "We accounted for that. If fragments were drifting away, you'd see stochastic wobble, not directional shift, and definitely not this clean." Choi frowned. "Maybe it's still noise. It's a 12 sigma deviation." Silence. No one breathed for a moment. 12 sigma. Statistically, that meant not random in the same way that a supernova isn't a candle blowing out. Marissa looked at their faces. Professionals, veterans, people who had built entire careers on the assumption that the universe plays by rules. Now they were staring at an object that wasn't. She felt cold. "So what is it then?" Choi whispered. No one answered, because the questions were forming in real time, silently behind every face. If it's not gravity, and not outgassing, and not fragmentation, and not instrument error, then what is curving that line? The next morning at JPL, room 4B, the one with the reinforced floor for hardware, felt like a war room. Screens covered the walls. Printouts littered the tables. Conversations were low, tense, clipped. Even the coffee machine was louder than usual, hissing like it knew something was wrong. Marissa sat at the main console as data streamed in from the Subaru telescope, the Gemini Observatory, and ESA's NEO Coordination Center. Every data set lined up. Every data set betrayed the same betrayal of natural law. Atlas was bending.
And now the deviation wasn't just measurable, it was accelerating. Dr. Choi appeared beside her, gripping a tablet. "I reran the outgassing model," she said. Added CO jets, dust drag, non-principal axis rotation, solar pressure anisotropy, everything. The maximum deviation we can justify is 1/3 of what we're seeing. Maybe it's rotating faster? Marissa offered weakly. Joy shook her head. If it were spinning up, the deviation would oscillate, but the curvature is stabilizing. You don't get stability unless something is steering it. She didn't say it aloud. She didn't need to, because the entire room felt the same thing crawling up their spines. At noon, they held the first high-level briefing with NASA leadership. The meeting took place in the big glass conference room overlooking the courtyard. Sunlight refracted through the windows, painting rectangular slabs of gold across the floor. Warm, bright, completely at odds with the cold tension gripping the room. Dr. Hassan Whitaker, head of the Planetary Defense Office, stood at the front. Before we begin, I need to emphasize that everything discussed here is strictly confidential. Until we determine the nature of these anomalies, this information does not leave NASA. Understood? Nods around the table. A few frightened looks. Good, Whitaker said. Proceed, Dr. Hale. Marissa stood, palms sweating, mouth dry. She tapped the remote. The first slide showed Atlas's predicted trajectory, a simple, hyperbolic path. Clean, elegant, exactly what physics promised. The second slide showed the observed path, a widening divergence. Whitaker frowned. What is the magnitude of the deviation now? A little over 1,000 kilometers at projected perigee, but growing. Rate of growth? Nonlinear. Increasing. Someone cursed under their breath. Whitaker's jaw tightened. Explain the cause. She inhaled through her nose. We don't know. That landed like a bomb. She continued, forcing her voice steady. We've ruled out instrument error, solar pressure miscalculation, observational bias, frame distortion, and common mode noise. Another slide. We've also ruled out natural outgassing. Current thrust levels from sublimation are insufficient by nearly an order of magnitude. Whitaker leaned forward. What about fragmentation? We see microfragmentation, but the nucleus, despite losing small debris, is shifting in a direction inconsistent with mass loss. Kessler from ESA spoke from the corner. Fragments drift away with the solar wind, but the main body is drifting sideways. A murmur swept the room. Sideways. Comets don't drift sideways. Whitaker rubbed his temples. All right, hypothesize. What's left? And there it was. That moment. The moment professionals dread. The moment you realize science has given you everything it can, and the rest is darkness. Marissa answered quietly. There is no known natural mechanism that produces this profile. Silence. Someone finally whispered, So, what does that mean? But no one touched it. Not yet. Hours passed. More data poured in. Deviation increased. By late afternoon, the modeling team had set up a constant recalculation cycle, updating projected trajectories every 10 seconds. Each new projection widened the gap between the expected path and the observed one. At 5:22 p.m., the gap hit a threshold. A notification flashed across the main screen. A soft chime, almost polite. JPL Horizons, update. Trajectory divergence exceeds 12 sigma. Confidence, 99.99989%. Recommendation, reclassify object behavior as non-ballistic. Non-ballistic. The term hung there, silent and terrible. Every scientist in the room felt the weight of it. Non-ballistic meant not following gravity. Non-ballistic meant something is pushing it. Non-ballistic meant no. Marissa refused to finish that sentence. Dr. Ramirez arrived an hour later with a grim face and a stack of printouts. "I ran an independent set of simulations," he said, "assuming minimal thrust, just enough to create the curvature we see." He placed the printouts on the table. Lines, arcs, deviations, one after another. "What does this tell us?" Whitaker asked. Ramirez tapped the page. "That atlas is directing itself towards a new intercept point." The words sucked the oxygen out of the room. "Intercept with what?" someone whispered. Ramirez swallowed. "We don't know." Just after sunset, they held an emergency roundtable with the asteroid dynamics team. The room had grown tense, humid with too many bodies and too much anxiety. Someone had brought in extra fluorescent lamps. Their cold white glow cast sharp edges across every face. Dr. Kavita Rao, the group's most senior orbital dynamicist, sat hunched over her laptop. Her fingers danced across the keyboard with furious precision. After 10 minutes, she looked up. "All right, I have something." Everyone leaned forward. "This deviation," she continued, "is not arbitrary. It aligns with a very specific vector." "What vector?" Whitaker asked. Rao hesitated. "An outbound curve, away from its original escape trajectory. Almost like it's repositioning." "Repositioning for what?" Rao's lips pressed into a thin line. "I don't know yet." The projector flickered on, showing a smooth arc representing the new trajectory. It bent outwards, then slowly upwards, like something correcting its aim. Marissa stared at it, her pulse thudding in her ears. It looked intentional. She hated that word. Her science education hated that word. But the line didn't care. The line just kept bending. By 10 p.m., they were exhausted, mentally, physically, emotionally. People paced. People muttered. People stared into space, searching for answers in the stale, recycled air. Then something shifted. Data from the Magdalena Observatory arrived, higher resolution than usual, and it showed something no one expected. Atlas's coma, the hazy cloud around its icy body, was not symmetrical, not chaotic, not natural. It showed filament structures, thin, straight, repetitive, aligned along the direction of the deviation. Marissa zoomed in. Enhanced contrast, filtered noise, structure repeated 3 times. Her breath hitched. "No, no, no, no." Ramirez rushed over. "What is it?" She pointed. "This isn't turbulence." The room crowded behind her. "This is pattern." Someone gasped. Pattern meant coherence. Coherence meant organization.
Organization meant stop. Don't think it, don't say it. Kessler grabbed the mouse, zooming further. "You're telling me this is natural?" he said, voice cracking. Ramirez swallowed hard. "I'm telling you I don't know what this is." The room descended into a frantic murmur. What if it's crystalline ice? What if we're seeing shadowing effects? What if... Then Choi said it. Clear, quiet, horrifying. What if it's structural? Silence fell like a guillotine. At midnight, another anomaly surfaced. Atlas's rate of rotation, previously stable, had begun to change, slightly, precisely, as if aligning itself. Rao ran numbers. "This isn't drift," she said. "This is orientation." Whitaker stepped forward. "Orientation toward what?" She hesitated. "Toward its new trajectory." Someone whispered, "Oh my God." By 2 a.m., new data from ESA arrived, and with it the nail in the coffin of every natural explanation. A small, steady increase in forward acceleration. Not enough to panic the world, enough to panic the people in that room. Forward acceleration requires thrust, Choi said flatly. But comets don't thrust forward, Kessler argued. Exactly. Ramirez shook his head. No known natural process gives you forward thrust at this distance. Not at this magnitude. Not this clean. Marissa stared at the projected curve on the wall, the clean white line bending more and more. It was beautiful. It was terrifying. It was wrong. At 3:17 a.m., all simulations reached the same conclusion. A new course was emerging. Not a random curve, a trajectory, toward a specific region of space. Dr. Rao spoke the words that froze the room. If this trend continues for another 48 hours, Atlas will leave its projected outbound path and enter a corridor that intersects the orbital domain of Mars. The room went still. No one moved, no one breathed. Whitaker finally managed, "Are you saying it's heading for Mars?" Rao nodded slowly. "No, I'm saying it might be steering toward it." Marissa felt the floor tilt under her. She gripped the edge of the console to stay upright. Steering? The universe didn't do that. Nature didn't do that. Not here, not now, not in front of them. Her voice came out hollow. "Please tell me this is wrong." Rao didn't answer, because the numbers, cold, emotionless, merciless, were already telling them the truth. Atlas was no longer just moving, it was choosing. Choosing a path, choosing a direction, choosing a target. And in that conference room, illuminated by the sickly glow of screens and the trembling reflections of people whose worldview was starting to crack, the realization settled like dust. This wasn't noise. This wasn't coincidence. This wasn't random. For the first time in their careers, for the first time in the history of observing objects from beyond our sun, they were watching something that might not be acting purely on the laws of nature. Something that moved with purpose. Something that corrected itself. Something that was bending the line. And Mars was now in the crosshairs. The room stayed frozen. Then, quietly, almost in a whisper, someone said what everyone else was afraid to think. "What if this isn't a comet anymore?" No one answered, because there was no answer. Only the silent, bending line on the screen, a thin arc carving its way through the solar system, defying every model, every assumption, every comfort that humanity had ever taken in the idea that space was indifferent. Atlas wasn't indifferent. Atlas was changing direction, and it was still accelerating. The first whisper came not from JPL, but from a cramped room in the Planetary Defense Coordination Office in Washington, D.C. Dr. Anika Torres had been reviewing orbital debris propagation models when she noticed the new update from the Atlas Working Group. She opened the file expecting the usual incremental anomaly, a few more meters per second, another decimal point drifting where it shouldn't. Instead, she found a red warning banner stamped across the report. Projected Atlas-Mars intercept now non-zero. Secondary risk to Earth under investigation. Her coffee went cold in her hand. For a long moment she just stared, unable to process the words. She scrolled down, reading the summary again, slower this time. Atlas's acceleration trend was holding. Its deviation curve had stabilized, then sharpened. The predicted corridor of motion had widened into a funnel, its center intersecting the orbital range of Mars sometime in the coming months. Even a near miss could eject fragments, dust, ice, and metallic debris into solar orbits that might destabilize, drift, or cascade inward. She felt a hollow ache forming in her chest as she read the newest simulation from the European Space Agency. A cloud of debris expanding from Mars's orbital altitude, intersecting with Earth's orbit, potentially producing a meteoroid stream far denser than anything humanity had ever seen. It wouldn't be extinction, but it could be devastating. Communications knocked out.
Satellites annihilated. Orbiting infrastructure shredded. Power grids destabilized. Spaceflight grounded. Air travel disrupted. Economies staggered. Earth wouldn't die, but the world humans knew might. She grabbed her phone and dialed NASA's emergency line. She said, "Patch me to JPL, immediate." Inside JPL's primary operations center, tension had settled like ash. Every desk was occupied, every monitor glowed, every voice spoke half an octave lower than normal. The world outside didn't know it yet, but the scientists in that room felt the shift in history like a tremor beneath their feet. 3i Atlas was no longer just a curiosity, it was a threat. A strange, deliberate, unnatural threat. Dr. Ethan Raines paced behind the main consoles, rubbing the back of his neck in a futile attempt to ease the growing pressure in his skull. He hadn't slept in nearly 30 hours. His eyes were bloodshot, his hands shook, but he couldn't afford to step away, not now. "Telemetry update incoming," Lena called from her station. The room quieted. On the central screen, the new trajectory points plotted themselves in yellow. The line pulsed faintly, like a heartbeat that didn't belong to nature. Ethan leaned closer. The curvature was still evolving, still tightening, still locking itself into a new, unnatural orbit. "It's stabilizing," Lena whispered. "It's not stabilizing," Rao corrected, appearing behind them with her usual grim calm. "What's the new peri-Martian distance?" Caldwell asked from across the room. Rao tapped her tablet. "Under 3,000 kilometers, possibly less." A collective breath caught in the room. 3,000 kilometers was nothing in orbital terms. That was clipping distance, practically grazing the atmosphere. Marcus muttered, "Comets don't skim planets unless the universe is drunk." "Or unless something's driving them," someone murmured from the back. Ethan turned sharply. "We are not assuming intent until the models rule out every natural possibility." But even he heard the lie in his voice. At 10:03 a.m., NASA HQ connected via secure call. Whitaker's face appeared on the center screen. He looked different than he had a day earlier, like he'd aged 10 years in a single night. "Give me the worst-case scenario," he said without preamble. Caldwell swallowed. "A direct impact with Mars. And if that happens—" She hesitated. "A megaton-level detonation, subsurface vaporization, a massive debris cloud." How massive? She tapped her tablet. "Potentially millions of fragments, many entering independent solar orbits." Whitaker nodded slowly, as though absorbing a physical blow. "And what's the risk to Earth?" This time it was Torres, patched in from DC, who answered. "Medium to high, long term," she said, voice tight. "Not extinction, but serious, dangerous, disruptive." "What time frame?" "Months for initial dust propagation, 1 to 4 years for debris to reach Earth-crossing orbits." The room felt colder. Whitaker sighed. "So we have two threats. The object itself," he nodded toward the inset that showed Atlas's headlong curve, "and the aftermath." "Correct," Caldwell said. "What do you recommend?" No one answered immediately, because there was no recommendation. No deflection missions, no interception capabilities, no plan. Not for this. Not for something moving this fast, with this precision. Whitaker exhaled. "We will need to brief the White House soon. Keep the data confined, continue analysis, close coordination only." Then his screen blinked out, leaving the scientists alone again with their uncertainty.
At noon, new data arrived. The acceleration increased, just slightly, just enough. Enough to make the hair on Ethan's arms stand up. Lena ran her hand through her hair. "The curve is tightening, even more." "How?" Marcus snapped. "How is it still changing? We've ruled out thermal forces, we've ruled out rotational influence. What's pushing it?" No one answered, because the truth was the same as it had been since the first deviation. Nothing we know of should be pushing it. Ethan walked to the display, breathing hard. The curve wasn't random. It wasn't drifting. It wasn't chaotic. It was mathematical, refined, coherent, purposeful. Every instinct in him screamed to say it, to break JPL's unwritten code of restraint. But once he said it aloud, there would be no coming back. "Ethan?" Lena asked softly. "What do you see?" He stared at the curve as if it were staring back. "I see a maneuver," he whispered. Ramirez swore under his breath. Caldwell closed her eyes. Marcus slumped into his seat. No one challenged the word now. Not anymore. It wasn't a comet's curve. It was a pilot's curve. An hour later, ESA reported a new observation. Atlas's coma was thinning. Not normal thinning, not sublimation depletion, but restructuring. The internal dust cloud was aligning, shifting, reorganizing along consistent geometric lines. Like scaffolding, someone said. Or internal bracing. Or compartments. "Stop," Caldwell snapped. "Enough. No speculation. Stick to the data." But the data was already spiraling toward one horrifying implication. Atlas was not behaving like an object. It was behaving like a vessel. Then, at 2:47 p.m., another development hit. "New propagation model from PDCO," Marissa said, rushing forward with a tablet. She placed it on Caldwell's desk. She skimmed the top line. Her face drained of color. "What is it?" Ethan asked. She turned the screen toward him. On it, a simulation. Atlas intersecting Mars's orbital zone, generating a debris cloud that fanned out like a cosmic shotgun blast. But the second half of the simulation was what froze every face in the room. The cloud drifted. Not outward, inward, toward Earth's neighborhood. "Jesus," Marcus whispered. "It won't be immediate," Caldwell said. "But the risk is real. Even a partial debris stream could disable satellites globally. Communications? Power? Navigation? All vulnerable." "How bad could it be?" someone asked. Torres' voice crackled over the call. She said, "Think Kessler syndrome, but natural, and directed at Earth." A silence followed that felt miles deep. "And that's if it misses Mars," Ramirez added. "If it hits, it won't destroy Mars, but the shockwave could push tons of particulate matter into highly elliptical orbits," Ethan finished grimly. "Some of those orbits would intersect ours." Caldwell rubbed her forehead. "So we're dealing with a dual-stage threat. The object itself, and what happens after." That evening, the team gathered for one final session to consolidate the day's findings. Faces pale, voices unsteady. Rao dimmed the lights and brought up the final trajectory overlay. Yellow line, the observed path. Gray line, the original gravitational projection. The yellow line bent cleanly, confidently, like a creature pivoting its head to look at something. Then the highlight appeared. A tiny circle. Mars's orbit. The yellow path approached it with uncanny precision. Ramirez broke the silence. "This isn't a drift. This is a rendezvous corridor." A rendezvous corridor. Everyone felt that phrase in their bones. Ethan took a slow step forward. "Are you saying Atlas is targeting Mars?" Rao hesitated. "I'm saying the math describes targeting behavior.
Whether that is intentional or the result of unknown physics remains to be determined. But they all knew how it looked. Caldwell spoke at last. Let's pause and remember we still cannot assume intent. We must avoid conclusion bias. But her voice lacked conviction. Lena's voice cracked. If this isn't intent, what else produces a guided curve? No one answered. Midnight again. The building quiet. The lights dim. The tension a constant hum. Ethan sat alone at the main console, replaying the last simulations. He watched the yellow trajectory over and over, tracing its arc toward Mars. But that wasn't what terrified him. What terrified him was the second half of the simulation. The ripple. The plume. The projected debris stream drifting across space like a tidal current. Crossing Earth's orbit. Crossing their future. His phone buzzed. A message from Lena. We need to talk. Now. Room 214. He stood and walked down the hallway, footsteps echoing in the silence. When he entered the small briefing room, Lena and Caldwell were already there. On the table sat a new printout. Just one page. He picked it up. It was a fresh projection. A worst-case scenario. If Atlas passed Mars at the currently accelerating curve and experienced structural rupture, natural or otherwise, the resulting debris trajectory intersected Earth's orbital plane within a year. Not guaranteed, not extinction level, but catastrophic. He placed the page down slowly. Caldwell watched him, her expression carved from stone. Ethan, she said quietly, we are past scientific curiosity. This is now a planetary risk scenario. He nodded without speaking. And the object? He finally asked. What do we do about it? Caldwell exhaled. We watch. We analyze, and we pray the curve stops bending. Lena looked toward the window, toward the invisible sky beyond it. But what if it doesn't? No one answered. Because they all knew it wouldn't. Atlas was still accelerating, still sharpening, still correcting, still choosing its path, and Earth had just entered the equation.
No one knew exactly when exhaustion became fear, or when fear quietly transformed into a kind of reverence. But by the time the fifth night arrived at NASA's Jet Propulsion Laboratory, the mood inside the darkened operations center resembled something ancient, something like a vigil. Scientists leaned over their consoles, not with curiosity now, but with the solemnity of people waiting for the universe to reveal a secret it had kept for billions of years. Three-Eye Atlas had stopped behaving like a comet. Now they were waiting to see what it would behave like next. At 2:02 a.m., the data stream hiccuped, then stabilized. Telemetry from the Deep Space Network blinked onto the main screen. Ethan Raines straightened in his chair, rubbing his aching eyelids open. Update transmitting, Lena called from across the room. Stand by for velocity profile. Every whisper, every rustle fell silent. Numbers rolled across the monitor. Raines's pulse slammed into his throat. Atlas had accelerated again, harder than ever. What the hell? Marcus breathed. Velocity, spiking. Trajectory, tightening. Acceleration, rising in perfect increments, as though following a script. Caldwell leaned in, voice tight. Confirm that thrust level. Lena ran the numbers twice, 3 times, hands shaking. It's real, she whispered. Atlas just boosted. Significantly. The room tensed. This wasn't drift.
This wasn't the gentle, eerie correction of the week before. This was power. Directed power. "Plot the trajectory," Caldwell said. The screen flickered. A new line emerged. A sharper curve. But then, something unexpected. The curve didn't continue tightening toward Mars. Instead, it began to stretch outward. A subtle widening at first, barely perceptible. Rao squinted. "Is that—" "Yes," Ethan said slowly. "It's turning." "But it's too early for a gravity assist," Marcus muttered. "Too far out. That's not how flybys work." "It's not a flyby," Choi said softly. "It's a bypass." The hair on Ethan's arms rose. A bypass? But why? Why now? Why this early? Atlas was still millions of kilometers away from Mars, far beyond any region where a natural object would begin bending around a planetary mass. This was not gravity's doing. This was something else, something anticipating, something planning ahead. The realization spread through the room like a cold draft. Caldwell steadied herself. "Overlay previous trajectory partitions." Ethan keyed it in. The chart updated. 3 lines appeared. The first, the purely gravitational path Atlas should have followed. The second, the anomaly curve that had threatened a near-Mars intercept.
The third, the new curve. A graceful, sweeping arc, not heading for Mars, but bending around it. Caldwell whispered it before she fully realized she'd spoken. "It's avoiding Mars." A hush swept the room, heavier than any silence afore. Avoiding. That word carried implications no one wanted to face. 30 minutes later, the meeting room was packed again. Across the table lay fresh simulations, hastily printed and already smudged from anxious hands handling them too quickly. Dr. Ramirez smacked a stack of them down. "Look at the acceleration vector," he said. "It's aimed tangentially away from the Mars intercept corridor. Not perpendicular, not chaotic, tangential. That's a controlled avoidance maneuver." "No," Caldwell said instinctively, but she didn't sound convinced. Rao pointed at her screen. "See this? The object begins turning long before reaching Mars's sphere of influence. No natural body anticipates a gravitational event." Choi added quietly, "Only guided systems do." Marissa Hale, who had barely spoken since the last night, finally stepped forward. Her voice was soft but steady. "Comets don't plan. Comets don't anticipate. Comets don't avoid. Whatever this is, it predicted the consequences of continuing toward Mars." The implications rippled through the room. A comet that anticipates? That strategizes? That corrects to avoid a planetary collision? Atlas wasn't acting like a projectile. It was acting like a navigator. At 4:11 a.m., a new burst of telemetry arrived. The yellow line on the main screen thickened as more data points filled in. The arc sharpened, no longer vague, no longer subtle. Dr. Kessler whispered, "It's accelerating through the turn." "That's impossible," Marcus said. "Nothing accelerates while turning unless it has thrust control," Raines finished. Even saying the words felt wrong, but there they were. "Let's look at the coma again," Lena said. She pulled up the highest resolution frames from ESA. The screen filled with the silhouette of Atlas, brilliant nucleus, icy halo, faint wakes of dust. But something had changed. The coma had stretched, not randomly, not chaotically. It stretched along the direction of motion, flattening slightly, then shifting like a fluid responding to an internal force. "Oh my God," Marissa said. "It's aligning itself aerodynamically." "That doesn't make sense," Caldwell argued. "There's no atmosphere out there." "No," Marissa said, "but there is directional thrust, and we're seeing the material respond to internal motion." Ramirez ran a derivative model. The result emerged in a single sharp line. "Thrust alignment confirmed," he said.
The air in the room changed, heavy, electric, alive. Atlas wasn't just accelerating. Atlas was orienting. The president was scheduled to be briefed at 9 a.m. NASA leadership wanted a unified explanation. But what explanation do you give when the universe stops following its own rules? The scientists worked frantically through the next hours. Every updated simulation supported the new conclusion. The object was neither colliding with Mars nor performing a gravity assist. It was bypassing Mars entirely, and doing so with impossible anticipation. Torres from PDCO joined via secure video. "What's the new Earth risk if it bypasses Mars?" "Unclear," Caldwell answered. "If the debris cloud scenario is off the table, that reduces risk, but this new behavior introduces new uncertainties." "What uncertainties?" Ethan stepped forward. "We don't know where it's going." Torres blinked. "You mean its outbound trajectory?" "No," he said quietly. "I mean its chosen trajectory." A slow chill filled the room. Chosen. That word again. Not assigned, not natural. Chosen. At 8:48 a.m., the simulation team uploaded the latest projection. It stopped every conversation in the room. Atlas had reached a plateau in acceleration, a stable, maximum thrust regime. It was now traveling faster than any previously observed interstellar object, faster than anything natural should under known physics. But that wasn't the shocking part. The shocking part was the arc. The bypass curve widened, then smoothed, then settled into a long, elegant trajectory, aimed cleanly past Mars, missing it by millions of kilometers. Too far to be an accident, too precise to be drift. But then, the arc didn't extend into deep space. It curled again, a second turn, a minor one, barely a whisper of redirection, but enough to send the projection team into a frenzy. "Run that again," Caldwell shouted. They did. Same result. Again. Same. A projection beam displayed the new path like a glowing ribbon through the solar system. Marcus whispered, It's not leaving the system." Lena shook her head. "Not yet." Rains felt his throat tighten. "Where the hell is it going?" Ramirez swallowed. "Whatever this is, it's not retreating. It's repositioning." When the sun rose, pale and indifferent, the people in that room were still standing in the same positions, staring at the new trajectory like it was a message written across the sky. Caldwell spoke first. Her voice shook. "In 40 years working with orbital mechanics, I have never seen a trajectory like this. It is purposeful. It is planned. And it is not aimed at Mars." No one spoke. Ethan finally forced the words out. "So this whole week, the acceleration, the bend, the near-intercept corridor, wasn't an approach," Rao finished for him. "Wasn't a mistake," Choi added. "Wasn't a malfunction," Marcus said. Ethan stared at the ribbon of trajectory across the screen. It was a maneuver, a deliberate bypass, a calculated path, a choice. At 9:03 a.m., a final data packet arrived. Temperature readings, coma density, nucleus light scatter. The coma had stabilized. The object had stopped shedding material. It looked almost clean, structured, streamlined, prepared. The room stood in collective silence. Atlas, silent, ancient, foreign, had entered a new mode, one no scientist on Earth had ever witnessed. Lena broke the silence, not with fear, but with something like awe. "It's behaving like it knows where it's going." Ethan felt something shift inside him, a realization, cold, simple, inevitable. It didn't miss Mars. It avoided Mars. And in that instant, the world they knew ended. Because comets don't avoid planets. Probes do. Vessels do. Navigators do. Things that care do. Things that plan do.
things that are not alone do. Caldwell exhaled shakily. God help us, because Atlas is not done. The screen flickered. The trajectory line pulsed. The new curve shimmered across the projection, a clean arc leading deeper into the inner solar system. Not toward Mars, not toward Jupiter, not outward, but inward, toward the sun and toward whatever else waited in its shadow. No one spoke, because they all understood the truth now. 3I Atlas wasn't visiting, it was arriving, and the next part of its journey, its purpose, its destination, its meaning, had only just begun.